All right, so again, it's the 11th of January, and we are on the beginning of Chapter 2, so I'm on page 47. The chapter is entitled Using Data, and as you can tell if you take a look on here, these are our objectives. I'm not going to read them to you, but much of the chapter is on the different data types. All right? You may or may not remember this if you were in the class last semester, but JavaScript really only had a few data types. All numbers were just of the number type. In C#, you've got a lot of numeric types. Some of those are listed here, and we're going to go through several of them right now. All right. In JavaScript, we had a Boolean data type. Here it's type bool, but it means the same thing, true or false. Here we have a type that's char. That's single quotes, stuff in single quotes. We'll talk more about the strings, name constants, and enumeration, and they'll show an example of this. An enumeration is a user-defined data type. So if there's not a data type, the one they give is kind of a classic one. You call it day of week. And the possibilities are Sunday, Monday, Tuesday, Wednesday, etc. Sometimes people create their own data type that's called month name, January, February, March, etc. So we'll talk about that. And we've looked a little bit at write line to write stuff on the screen. Now we're going to look at read line to read input from a user. All right. So one of the first things they talk about here is they talk about constants, literal constants, and variables. So if you imagine here, this is not a real program that I'm writing. In fact, I think I did bring up Visual Studio. There we go. So if I come through here and I say this, int age equal 21, that's a variable. And that's a variable that's of type integer, meaning it can only hold a whole number. So you'll notice if I come in here and try to put in 21.3, I get an error. Did you see how it went from green squigglies? That green squigglies is just a warning because it's telling me I've got a variable I haven't used yet. But when you get the red, there's an error. All right, so if I try to compile this right now, it's going to come back and say that I have an error. When you get that, literally 100 times out of 100, you want to say no, because then at the bottom it'll show you what the error is in your error window. All right, it says cannot convert type double to an int. That's what I'm attempting to do right here. I'm attempting to take something that has a decimal point in it and assign it to something that says whole number only. All right, same kind of thing would happen if I do this. I'm doing the same kind of thing there. They're both erroneous. All right, so I can do stuff like this. I can say, for example, int age equal 21, double salary equals, and let's just say the person makes $55,555.55, something like that. Again, I'm getting those green squiggles because it says I'm assigning them a value and I'm creating the variables, but I'm never using them. All right, I can have a bool, and I can call it married, and I can set it equal to true. Same kind of thing. All of those data types should make sense to you. All right. Now, there's type double and there's type float. If I put a float in here and I say salary like we did here equals 55555.55 like that, all right, I'm going to get a couple, well, let's call it salary too because I already created salary. I'm going to get this. And the reason I get this is because by default, when you put in a number with decimal places, the system thinks that it's a double. So if I want to specifically say that it's a float, I have to put an F on the end. All right? You got to learn that because that's the exact same way it is in Java. All right? And it doesn't matter if you use a lowercase f or you use an uppercase f. So you say, well, how do I get around that? Don't use floats. Just make everything a double. What ends up happening is you're wasting a little bit of memory. All right, so kind of if you look at memory like mailboxes, instead of using 4 mailboxes, you might be using 6 or whatever. It's not a big thing. All right, and that's how most people get around that. Now, what if I want to, what if I'm doing a program where I'm going to be doing a tax rate? And let's assume that once Trump becomes president, he decides everyone's going to be taxed at a rate of 35%. I'm not saying he's doing that. I'm just saying just for the sake of argument. So I could come in here and say const double. A const means that it's a constant. It's something that cannot change when the program runs. All right? So const double, and by convention, you don't have to do this, but I want you to because everyone does, is you put constants in uppercase. That sends a subliminal signal to the person looking at your program. Oh, that's a constant. I can't change it. So the only time that that can appear on the left-hand side of an equal sign is when you're first giving it a value, like that. So do you understand that these are variables? These can change throughout the program if I want them to. This is a constant. It cannot change. Does all that make sense? It's all on the test. All right? It's all on your next written test. So if we go back and we look on here, a data item is a constant when it cannot be changed. I just showed you that. Now then they talk about a literal constant. That's a little confusing, but if you take a look up on the screen here, oops, make that here. Everything to the right of the equal sign is a literal constant. What that means is I can't take any of these, this, or this, or this, or this, or this. None of them can appear on the left-hand side of an equal sign. I can say age equal 21. I can't say 21 equal age. It doesn't make any sense to the system. All right, it's like I'm trying to give something that's got a constant value a new value, and you can't do that. So that's what they're talking about, and it's a little bit confusing. A variable, we already know this. It's a name, location, and memory that can vary. On your next test, I'll tell you that right now. All right, what I just showed you with the int and the float and the double and the bool, those are all called data types. So the idea, and I want you to, if you look up here, because I want everybody to see this, that let's suppose, I'm going to grab all this stuff in here, kind of a little hint for you, just so you know this. Notice I'm going to highlight all those at one time. If you look up, please look up on the screen here. You see right here this thing that looks like this. It's a little bit down below help, but there's two of these together. If I click this one, it allows me to comment a whole bunch of lines out at once. If I click the one next to it, it uncomments. Just a little shortcut for you. So if you want to comment out a whole procedure, I mean, what's the other thing I could have done? I could have come up here and done a /* and then come down to the very bottom and put in a */. I could do that also. So there's a lot of different ways that you can comment. All right, but if I come through here, and so we're talking in here about data types, etc. But if I come through here and I do this, this isn't on a test, but I want you to understand this. Here we said int age equal 21. If I do this, that is what's known as a variable declaration. So what I'm saying is age can only hold whole numbers that fall within a certain range. We'll talk about that range in a minute. But does int make sense to people? Whole number only. So that's a variable declaration. If I come through here and instead of saying this, if I would have said, so instead of the one I put in here, if I would have put in this, if I grab this that we did right here, that is both, a variable declaration and a variable initialization. So not only am I declaring a variable, that's the declaration. That is the initialization right there. Does that make sense? When you create a variable, you can both declare it and initialize it at the same time, or you can declare it and initialize it later. Does that make sense? When you create a constant, you must initialize it when you declare it. Does that make sense? Those are all things you're just going to have to get ingrained in your head. All right. The good news is if you screw up, by and large, the compiler lets you know. All right. You'll start getting syntax errors. All right. So they talk about this, and they're going to show you this table. I've mentioned Unicode before. Hopefully everybody has heard of it, knows what I'm talking about when I say Unicode. All right, it's a character set. Back in the day, back in the 80s, 90s, whenever, everything that was done based off of what was called the ASCII character set. And ASCII is an acronym that stands for American Standards Code for Information Interchange. The bad thing about ASCII is it only allowed 256 different characters. That was it. Well, when you think about it, that probably is good for the English language, but once you start bringing in other languages, that's not enough room. So what they did was they created a new character set that they called Unicode that now is somewhere around, has about 100,000 different characters in it. Out of those 100,000 characters, the first 256, the first ones, are this. Okay? And a character set basically is just the way the computer, if you type in an A, that, whether it's an uppercase or a lowercase a, that A has to be converted into a series of zeros and ones because that's all the computer understands. All right, so the character set is how you do that transformation. All right, so there is a table in the book, and that table, it takes up almost all of page 49, and it shows you the different data types. Byte, short, int, long, float, double, decimal, char, etc. So let's break these down. Everything that you see that I've highlighted here, everything here that is in blue, those are all whole numbers. All right? It's funny, very few people use byte, but byte really has a lot of usage. For instance, if I was doing a program about age, I said int age. That means your age could be negative 2 billion to positive 2 billion. That's kind of stupid when you think about it. But you very rarely, if ever, see somebody say byte age. All right? Almost all the time when you want a whole number, you use int or some flavor of int. And you'll notice the difference. A 32-bit int has a range of what? All right? Negative 2 billion plus to positive 2 billion plus. If you put a U in front of it, the U means unsigned. So that means you can't have negative numbers. But I'm not going to read any of these or any of the rest of these to you. But the idea is they all have different ranges. Does that make sense? You're not asked anything like that on the test, like what's a range of this or whatever. Okay? But what you find most often is people use 32-bit ints for almost any time they need a whole number, int and int, which means it's a 32-bit int. They almost always use double, even when decimal's available. And as needed, they use char, bool, and string. I'm not going to talk about object until we get to Chapter 9. So don't worry about that one at all. Again, I'm just going to keep plowing through here. If you have any questions, I'm going to take for granted that you're going to ask. Okay? So when you declare a variable, this is what I showed you before. You've got to give it the data type, like int, the name, like age, and optionally you can give it an assignment. But you must, whether you say int age or whether you say something like int age equal 21, you must put a semicolon at the end. And a couple of you have asked me questions about the debug assignments. All right. So let's say you're doing that. One of the debug assignments, I believe, maybe it was the first one, they left all the semicolons off. If you don't want to literally key those in, if you want to do this like this, you can. So let's say they spell right line wrong. If that was the only error that you saw in there. If you want to, you can just write what the problem is. Didn't put semicolons. Spelled right line wrong. Capitalization was wrong for right line. So just let me know the line that was wrong and the problem. If you want to do it that way, that's fine too. All right? The equal sign is the assignment operator. I will guarantee you, what I'm about to put on the board here, just so you see it, is on the test. Single equal sign means assignment. Double equal sign means equality. What does that mean? That means if I say this, if age equal 21, that's an error. Did everybody hear that? That's an error. Because I can always assign 21 to age as long as age is an int or some number, some kind of a number. So if I want to check to see if the age is 21, I must put in 2 equal signs. All right? That is on the test. And again, as the author says, come on back now. As the author says, you can't do this. Where is it? There. You could say int my age equal 25. You can change it later, but you cannot say, for example, 42 equal my age. You can't do that. It doesn't make any sense. You can never put an actual literal value, true, false, a number, whatever, on the left-hand side of an equal sign. If the, I always used to give this example. You might laugh. Maybe it's funny, maybe it's not. I always said that working with a computer is like working with my wife. All right? Because if as far as the computer is concerned, like as far as my wife is concerned, if I don't do it her way, I'm wrong. And that's what the computer feels. If you don't do it the way the computer expects it, you're wrong. And you'll have to change it. All right. She's got her famous 2 truths and a lie in here, so you can look at those if you're so inclined. All right, so let's look at this. This right here is a console app. Everybody hear that? This is a console app. Please look up on the screen right here, because what I'm going to do is I'm going to go back to this, and everything we put in here so far, I'm going to remove. All right? So I want to say here, int age equal 21. Then I'm going to say here, right line, I wish my age was, and then I say here, plus age. Now, does it make, I'm asking you this, does it make sense to people, we'll fix that right line in just a minute, does that make sense to people that should write on the screen, I wish my age was 21? Does that make sense? All right. Well, notice it says right line, and there's the squiggles there, because what the system is expecting is for me to write system.console.writeLine. Notice how it went away? But I've already got here using system. So I can remove that and just write console.writeLine. And notice there's still no error. Okay? There is no direct. You can't say using console. You can't do that. That doesn't exist. But what you can say, if you want to, is using static system.console. And that'll get fixed. You might want to write this line down. I tend to put that at the top. Anytime I'm writing a console application, remember what a console is? It's not a GUI. It's not a graphical user interface program. So anytime you write a console program, it's a good idea to put that right at the top. Let me get all this garbage that's here now. And it's a good idea to put that there, because then, once you type that in, using static space system.console. Once you put that in, and I'll come right back up to it, please look on the screen here. Now, all I need to put in there is right line. Notice that there's no error message right there. All right, but you need to say this at the top, using using space static space system.console. If you forget, you say, or I didn't write it down, or I got an error, it's in your book, using static system.console. Look at the program on page 52. It's right there. So again, another thing to realize about this is if I run this right now, it's literally going to print on the screen, I wish my age was 21. The problem is it's going to print, it's going to go like that. You're not even going to see it. If you don't believe me, I'm going to save this and I'm going to run it. So what happened? It printed, but I didn't tell it to stop so I could see what was printing. So typically when you put in a write line like this, if you want the system to stop, then afterwards you put in a read line that's empty like this. All right? And that's only for a console program that you have to worry about that. Please look up on the screen now, and I'll come right back to the code. But notice now, see how it says I wish my age was 21? Now the read line made it stop until I put in anything I want, or nothing, but I hit the enter key. Now as soon as I hit enter, boom, it comes back again. So if you write a console program and you want to be able to display your text and see it on the screen, you must put a read line statement at the bottom. Does that make sense? It's just one of those necessary evils, for lack of better words. All right? So if we use the one that was in the book here, that should write the money is $39.45, right there. Okay? There's a write and a write line. It doesn't really matter. There's a lot of ways that you can do it. But the author shows you many ways of going through this. That's why I'm trying to hit the highlights with you, but I'd strongly suggest you read the book. Okay? Now the problem is, what happens when I want to start displaying variables? I can do this, and I can say the money is, and that'll put in there, okay, that'll put in there, well, whatever it was, 39.45 or whatever the heck it was. There it is, 39.45. So that will print the money is 39.45. But if I do it like that, I have to put my dollar sign in. And what if instead of 39.45, it was 123.45? No, 1234.56. If I don't remember the dollar sign, it's not put in there. I have to manually put in the comma. That's a pain in the butt. All right? So what I want to show you is, because it's not shown right here in the book, I'm going to grab all of this code right here and copy it to the clipboard. And I'm going to put it right into the program. I'm going to remove what's here. I'm going to keep that read line there. Okay? And now I've got double, some money equals this, string, my sentence equals string format. The money is exactly, write line my sentence. This should say, the money is $39.45. Does that make sense to everyone? That's what it should say. So let's run it and see if it does. The money is $39.45. Good. Exactly what we wanted. All right. The problem is, what if we get this? Instead of $39.45, what if it's $39.5545? Okay? I'm going to save that, run it again. It's 394, that's not bad, but what's missing from there? A comma? Not like it's a big thing, but first of all, it's bad because it's a comma. Second of all, it's bad because I have to put the dollar sign in there. So what I'm going to show you right now is discussed in the book, but not yet. Okay? When I put that 0 in there, I can put after it colon C. That means format it for currency. So I don't even need the dollar sign in there anymore. So notice that when I do that and I run it again, see how it put the dollar sign in for me, and it puts the comma in. And it automatically puts it to 2 decimal places, even if it's more than 2 decimal places. So I'm going to suggest that when you write console programs, right from the start, right from the get-go, you start formatting them. All right? So what if I didn't want that? In other words, what if I said this? What if I have here double pi? And pi is equal to 3.14159. I know it's more than that, but you get the idea. All right, so I'm going to put here pi. All right, well, the problem is if I run this now, that doesn't look right, does it? Because pi is not in dollars and cents. What if I wanted to print here, and I want it to print, but I only want it to print to 2 decimal places? Then I can put here, what's that? Well, I've told them about this. They know. So I'm going to put here F2. F means floating point. And you use F, you don't use D, whether it's double or not double. But notice now I've got F2. So now when I run it, brother. See how it's to 2 decimal places? there's a good chance next semester that the afternoon class is going to meet next door there. All right, because I think Ryan's got a class in here, so my morning class will meet in here and I'll go there for the afternoon. That's the way it looks. That's actually good news because that's not a screwed up projector. All right. So that was a lot to throw at you, but I want to make sure that at least you've heard it. All right. And the author gives all sorts of examples. Page 54, there are examples. Page 55, there are examples. All right. These things that you put inside of these curly braces right there, they're known as placeholders. And I'm going to show you an example, and you'll see some more as we go on in here. All right. This whole thing right here where you put, when we do this or do something like this, that's known as a format string. Why am I telling you that? Because it's on the test. There is a question, it's probably one that's the fill in the blank one or whatever. It says, what is this? It's a format string. It's what it's referred to as. All right. So the integral data types, integral is short for int. Or int is short for integral, I mean. There's byte, there's sbyte, there's short, there's ushort, int, uint, long, ulong, and char. Now that one might look a little weird. It's like, why is char one of the number types? Because if you really know what you're doing, you can print characters out as either characters or as numbers. I don't want to get into that right now, but you can do that. All right? But the idea is the integral data types store whole numbers. What does a whole number mean? I'm asking you, what does a whole number mean? What? No decimals. Perfect. No decimal or fractional component. All right? That in some form or other is on the test. So they go through and they give you some examples in here that use integers. Again, you are not required to do the examples that are in the book as far as the author on with these you do it's. There's one on page 58. If you're struggling in here, I'd suggest that you start up a new project and you key in what they put in here. All right? And I know when people say, well, I'd like to do it, Jeff, but I don't have the time. I get that. All right? But the bottom line is, if you do your first hands-on test, which again is Tuesday, but when you do your first hands-on test, if you blow it, then you might want to go back and start keying some of the stuff in. All right? All right, then after the integral data types, you've got the different floating data types. Float are double. There's three. There's double, there's float, and there's decimal. Decimal is actually not used that often. Unless you're doing monetary things, decimal is not used very often. All right? It's not that it's wrong or that it's bad, but it doesn't tend to, if I'm working for NASA, that's a scary thought, but let's just say I was. If I'm working for NASA and we're going to send somebody to Mars, if you're off by a billionth in your calculations, that could be the difference between hitting Mars and missing it. All right? So if you're doing some kind of a job like that, then it really matters. Okay? If you are writing, let's say that you're writing a loan amortization table. Does everybody know what a loan amortization table is? It's like if I'm going to buy a house. So let's say I buy a house, and I'm going to buy a house that's $150,000. And I have $50,000 to put down. And I'm going to take a 30-year mortgage. An amortization table will tell me over that 30 years, it'll show me my payments, and it'll show me how much is going to interest and how much is going to the actual $100,000 I borrow. Does that make sense? All right. In those cases, you'd probably want to use a decimal type. Because if you used a double type, when you got all the way through it, you'd probably be off by a few cents. If I never told you my story, I thought this was funny. I paid off a car, and I financed it through the bank near where I was living at the time. And I was expecting the title and expecting the title and expecting the title. I didn't get it. Then I got a message from the bank, and it was actually an angry letter. Well, it was their program that screwed up. they said I still owed 3 cents. And I owed 3 cents because their program was wrong. Okay? I thought of actually taking that card, taping 3 cents to it, 3 pennies, and sending it back to them. But instead, I just sent them a check for the 3 cents. All right? I heard about it later, too, because I knew somebody who worked at that bank. What an ass I was. Okay. But with floating point versus double, it's how many significant digits usually you care about after the decimal point. All right? And computers, if you've never heard this shtick before, if I'm working with a computer and I write a program that adds 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0.1, and I do this 10 times, all right? If I do that 10 times, the answer is not going to be 1.0, depending on the computer that you use. You'll either get something like 0.9999637 or 1.0000158, something like that. Because computers are not exact animals, all right? And it's just the way that stuff is held inside of the computer. You're going to, if you're working, if that's money, you're probably going to want to use decimal, all right? But if you need to have a lot of precision to the end after the decimal point, then you're going to use either double or you're going to use float. And that table that was at the beginning of the chapter shows you the different amounts of precision and the like that's in there. And it's mentioned here too. So a double can hold 15 to 16 significant digits of accuracy. All right. The decimal, again, greater precision but a smaller range. So it's typically used, all right, with most monetary calculations. Here's the F, like I mentioned to you before, that if you say something is float, you must put an F after it. Whenever you're giving it a value, it can be uppercase or lowercase. You can put a D with doubles. No one does it. But you can if you want to. All right. Then they talk a little bit more about formatting in here. In fact, there is a table on page 61 in the book. Remember earlier I showed you that example where we put here, I originally had a C there. That C can be uppercase or lowercase. Then I showed you an F with a number of decimals. That can be a lowercase or uppercase. All right, and all of these things in here are explained on the table on page 61. You're probably going to use F or C almost 100% of the time, unless you do something with exponential notation. Very few people get into jobs where you use things like that. So it's just the first two that you have to worry about most of the time. And again, she gives you some examples. All right? So there's that C for currency. And please look at this. I think this is on your test, and I never go over it, but I think that one of the words that's on there for your test is culture. And a culture, this is on page, halfway down on page 62 in your book. You might want to just put a little mark on it or however you do your studying. A culture is a set of rules that determines how culturally dependent values such as money and dates are formatted. Now, I have never heard that word before, okay? But words that you do hear sometimes are localization instead of culture. That one I've heard. I've never heard culture until I saw this book. All right, the arithmetic operators. This is not a joke. Am I right in assuming that everybody understands plus, minus, asterisk for multiply, slash for divide, and the modulo is the percent sign? That's the remainder operator. Typically, you use modulo if you're working with hours, minutes, seconds, or dollars and cents. All right, there are other uses, but those are probably the two most popular. Notice C# does not have an exponential operator built into it, but instead you use what's called math.pow. Do you have to worry about that? In chapter 8 you will, 8, 9, and 10. But for now, no, that's fine. So another thing that's on the test, this is on page 64. What is operator precedence? I don't know about you, but I remember for me it was in 8th grade when the teacher wrote on the board one day. We didn't talk about remainder operators then. But the teacher wrote, you always do multiplication and division before you do addition and subtraction. And if you want to do the addition and subtraction first, you must use parentheses. All right? That's operator precedence. Does that make sense to everyone? So what we're adding here is modulo. So that says you're going to do addition and subtraction after you do multiplication, division, and modulo unless you use parentheses. All right, that's what operator precedence is. It's what, if you got a bunch of different things in a big expression, what do you do first? When in doubt, parenthesize. All right, one of my teachers in high school always said that. If we were going to do something like this, that you see there in blue or kind of gray right there, if we didn't put that in parentheses, he'd take off. He said, we want you to leave no doubt. In fact, usually what he would do would be, he would put parentheses around the whole thing, and then if he wanted to do the addition first, he would also put another set here to leave no doubt. All right? All right. There's the summary of it, the same thing I just told you, that's on page 64, right near the bottom of the page. Okay? There are shortcut operators in this language. And I'm going to show you the shortcut. Let's just put it on here. All right, let's go back to age. Let's see. We're going to put int age equal 21, and we're going to put int new age. All right, we're going to set it here equal to 0. All right. Then here we're going to say new age plus equal age. All right, it looks a little weird. That's just a shortcut for saying new age equals new age plus age. You see where that's a shortcut, the plus equal? All right, and just so you know, there are a total of 5 of them. There's plus equal, there's minus equal, there's times equal, there's divide equal, and there's modulo equal. And that would be here a minus, a times, a divide, and a modulo. Again, I've said this to you before. Right now, I'm striving for you to understand things. If that confuses you, if using these here confuses you, then just do it this way. I wouldn't take off for something like that. What you'll find is this, the stuff that you see here in black, will execute faster than the stuff that's in here in green. The reason for that is the computer has less work to do. You're using a built-in operator to make it run a little bit faster. We're not that concerned with speed in here right now. Okay? So those are the shortcut operators, and they're shown in the book. There's a bunch of them shown here on pages 65 and 66. Okay? How about this one? And again, I'll guarantee you this is on the test, what I'm going to show you right now. That if I do this, we'll get rid of all these examples. All right? Maybe you remember this from JavaScript, maybe you don't. If I do this, new age equals plus plus age. Anybody remember what that does? What does a plus plus operator do? It increments by 1. Minus minus decrements by 1. All right? When we get done with this, if we put this in here like this, when we're done, this changes both values. Now, new age is equal to 22 and age is equal to 22. This line right here, that line, is the same thing as if we did this. Plus plus age, which means add 1 to it, new age equals age. Does all that make sense? This is called the pre-increment operator because the plus plus is before you do anything. Now I'm going to grab this same code. I'm going to move down a few lines here. All right. I'm going to keep that one up there. In fact, can I keep them both here? There. And I'm going to paste this in. All right. If I put in here instead of plus plus age, I put age plus plus. Now it's as though I reverse the order of these. Why does that matter? Because now new age is equal to 21 and age is equal to 22. That's called the post increment. So with the pre-increment, you increment and then assign. With a post-increment, you assign, then you increment. And again, if that confuses you, don't do it as one line. Do it as 2 lines. I want you to understand what you're doing. I will tell you that once you get out in the workforce, if you're told, Amin, this is your code. This is what you're responsible for. Once Amin is really proficient at what he's doing, if he can take 1,000 lines of code and cut it down to maybe, let's say, 400, now that's 60%. It's not 60% less work he's got to do, but it's 60% less code that he has to maintain. Does that make sense? So you're always looking for ways to make it easier for yourself. And that's not cheating. That's writing code the right way. But for now, I don't care which way you do it. All right? But there is some kind of a question in here that asks something like that. All right? So if you need more on that, you want more, the increment and decrement, I see the prefix and postfix, they're mentioned on the bottom of page 66. And then there's a program on 66, 67, and 68. That's why I'm telling you. You know, there may be one or more of you in here right now who are like, okay, I'm listening to every flipping word you're saying and I'm understanding. That would be absolutely nothing. And if that's the case, it's going to be very important for you to start keying in these examples that are in the chapter. All right? I can't force you to do it, but it'll be reflective in your grade. If you don't do it, you don't understand it. All right? There's only so much I can explain. Then I'm just going to tell you, you're going to have to key in a couple of examples. And ideally, once you do that, it'll start making more and more sense. If I was going to spend time going through this book, I don't give a darn about these 2 truths and a lie things that she puts in there. But she's got some good programmatic examples. And by and large, they're pretty short. These you-do-its. So if you're confused, I would start going through those you-do-it programs. Bool. What 2 types can bool have? True and false. That's it. Now, to the computer, you might find this a little bit confusing. To the computer, typically, false is 0 and true is just about anything else to the computer. But the way we look at them is true, false, and usually we equate 0 with false and 1 with true. All right? If you look at it through what's called Boolean logic, true is sometimes, instead of saying true, you say on. Instead of saying false, you say off. All right? Comparison operators. I'm asking because I don't know. Does everything that's in there make sense to you? And if it does not, please ask. Remember, for equality, it's a double equal sign. And for inequality, it's an exclamation point, the last one, equal sign. In some languages, just to show you this, I'll make this really small. Oops. Come on, move. Okay, well, I'll do it here then, that's fine. In some languages, what you do when you're doing not equal, I'm gonna have to make it big as, come on, would you? There you go. With some languages, you can do this. You can use a less than sign followed by a greater than sign instead of this. When we do the database stuff in here, you can use either one of those, but just use that. Yes?
What's the difference between a single equals and a double?
Single equal means assignment. So that's when you said int age equal 21. You're assigning 21 to the variable age. If you try doing this, you get an error message. All right? This in this case, it's true, right? Because age is equal to 21. Now, it's false. Would you agree with that? But if I do this, that looks a little weird. That's true. That literally says, can I assign 21 to age? Why can't you? So single equals assignment, double equals equality. All right? And again, she gives you the chart here on the top of 69. And then what does she do right away? Well, on page 70, she gives you an example. Says you do it, working with Boolean variables. So again, if you're confused, go ahead and key in the program. It's not a long program, that's it. And she even shows you on the next page, hey, if you did it right, it should look like this. To me, that's like a godsend. If I'm not understanding this stuff, I'm going to be keying in every program. All right, understanding numeric type conversion. Now, I don't want to go into a big thing on this, but I want you to hear a couple of words. Those are implicit versus explicit. All right? All right. What's the difference? If something is done implicitly, that means either the computer or the software does it. But if the computer does it or the software does it, who's not doing it? What? Yeah, you. And if it's explicit, you do it. Does that make sense? And if you're still confused, let's say that Dominic creates, maybe have you ever seen that vacuum cleaner, that robotic thing that it's a circle and it goes around? Let's say he what is it? Roomba. Okay. So he's created that. All right. If all he has to do is turn it on and the clean thing does it itself, then the floor is being cleaned implicitly. If he's got the old type like I have that you have to sit there and push it back and forth, he's explicitly doing it. Does that make sense? Now, I'm not saying this is on the test, but in virtually every programming language, at one time or other, you will hear something done implicitly versus something done explicitly. So if it's done implicitly, the computer or the software is doing it, which means it happens without you having to do anything. If it's explicitly, you must do it. Does all that make sense? All right. Because they talk in here about implicit conversions. I mean, again, implicit, meaning the computer will do it. So if I do this, I'm going to show you one example just to try to keep it simple. If I do this, so if I come through here and I've got my age, and don't ask me why I would ever want to do this, because it'd be stupid to do. But I want to sit there and I want to add to age, I want to add pi. Okay? Now, that's not a problem. So now I'm going to say here, double ANS for answer, and that equals age plus pi. Well, that'll work, but what the system has to do, as far as internally in the computer, it only wants to add apples and apples. So what it does is it changes age to 21.0. So they're both doubles. Does that make sense? It only wants to add things of the same type. You don't have to worry about that because it's done implicitly. All right? And all the different conversions are shown again on the bottom of page 71. 72, she's got more two truths and a lie. Then on the bottom of page 73, I should say, On the bottom of page 73, she talks about char. And again, this is a little confusing, not what's shown here, but I want you to understand something. First of all, chars must be in single quotes. Everybody hear that? Must be in single quotes. All right? Not like JavaScript where a string can be in either single or double quotes. Here in C#, strings must be in double quotes. Chars must be in single quotes. All right? If I asked you, what's this? What's the numeric value of that? It's 0 because it's a character 9. It's not the number 9. If I try to use that in math, if I do it in JavaScript's, remember JavaScript I told you is kind of a lazy language? Sometimes it'll actually go and convert it to a number. This language never will. All right? It'll never treat that as the number 9 unless you run what's called a conversion function on it. Again, those are single characters as far as the system is concerned, just so you know. There's only 2 that probably you'll ever need to worry about. And that's this one, \n for new line, and it's this one, \t for tab. Those are the ones you're going to use virtually 100% of the time. But there's a chart on page 74 in the book, so if you do want to use those, some of the rest of them, you can. On page 75, come on, stop it. No, don't do that. Well, otherwise it's going to be a good time for a break, right? All right. On page, yeah. All right. I was hoping we could finish before the break, but I'll tell you what, let's do this. We've got about, chapter goes to like page 89, okay? So we got about 15 pages. I'm gonna probably have to restart this. Let's take a break. It's 9:49. Let's just take 10 minutes. When we come back, we'll take about 15 or so more minutes. We'll finish the chapter. We'll go through the review questions, and we'll do the test review. All right? Then I'm gonna let you play, do whatever you want to do for the rest of the period. Tomorrow, we're going to actually write a couple programs just in the first hour or so, and then you're going to have the rest of the period for lab. Friday then will be just the written test for Chapter 2. Okay? And the hands-on won't be till next Tuesday. Let's take a break.